Hello everyone, my name is Rela Dinesh from CSITA section. My techno concept of data structure is graph isomorphism problem. Let's see what is graph isomorphism problem. Introduction. The graph isomorphism problem is a fundamental problem in data structures. It involves determining whether two graphs are isomorphic if they can be rearranged to be identical. Graph isomorphism has applications in various fields such as computer vision, chemistry, and network analysis. Here we can see the two different shapes labeled by G and G dash with G1 and G2 we can consider as G1 and G2. Here we can see the two figures have same number of vertices but they have joined in different ways. This is a perfect example of isomorphism. Now we will see what is the definition of isomorphism. Graph isomorphism refers to a concept of two graphs having same structure. Two graphs G1 and G2 are isomorphic if they exist a bijection between their vertex and preserves agency. Isomorphic graphs have the same number of vertices and edges but their labels and position may differ. If we are given two simple graphs G and H, graphs G and H are isomorphic if they are structures that are preserved one to one corresponding between vertex and edges. In other words, the two graphs differ only by the name and edges and vertex, but the structure equivalent as noted by Columbia University. The graph isomorphism problem is a challenging problem in computer science. It is currently unknown whether it can be solved in polynomial types or in NP complete. Despite extensive research, no efficient algorithm has been found to solve the problem for all cases. Various approaches have been proposed to solve the graph isomorphism problem. One common approach is to use method checklist. Another approach involves using relabeling, in which we can label the vertices by checking the degrees. Here we can see the graphs that G and H. Here they are counting the edges by 1, 0 by numerical order 0, 1, 2, 3, 4, 4, 5, 6, 7 like that. Now we will see method 1, checklist method. Now we will see the checklist method. Look at the two graphs. Are they isomorphism? Isomorphic? Okay. In the above checklist method, all we have to do to ask the following questions to know whether the graphs are isomorphic or not. A1, A2, 3 graphs. Okay. Are the number of vertices is both graphs are the same? Both vertices have 4. Are the number of edges in both graphs are the same? Yes, both graphs have same. Is the graph sequence in both graphs the same? Yes, each vertex is of 2 degrees. Degree 2. If the vertex in one graph can form cycle of length k, can we find the same cycle length in the other graph? Yes, each graph has cycle of length 4, and if we can answer yes to all the 4 above questions, then the graphs are isomorphic. In other words, they are equivalent graph just in different forms. Method 2, relabeling. In addition to counting vertex, edges, degrees and cycles, there is another easy way to verify isomorphism between two simple graph relabeling. Suppose we want to show the following two graphs are isomorphic. Here we can see that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 vertices, and in this graph also having 5 vertices. First, we check vertex and degree and confirm that both graphs have 5 vertices and the degree sequence in ascending order is 2, 2, 2, 3, 3. Okay. Now we methodical start labeling vertex by beginning with vertex of degree 3 and marking A and B like this. A, B. Now next to C. Here D like this. Next we notice that in the both graphs there is a vertex that is adjacent to both A and B. So we label this vertex C in both graphs. AB, the opposite side is C. We can observe clearly. We can observe clearly this. The C is opposite side of AB is C is opposite side of AB, adjacent side of AB. Here also we can see that AB adjacent side is C. Clearly we can see that. This now follows there is a two vertex left and we label them according to DE, where D is adjacent side to AE, where D is adjacent side to AE. Okay. And finally, we define our isomorphism by relabeling each graph vertex one to one corresponding. Okay. In this relabeling, we can see that we must find the adjacent sides of a vertexes. First we take the two vertices A and B and we find the opposite side, that is C. Okay. Now we consider that now we yes, here we can see that AB, we consider AB as a vertex and the adjacent side is C, like this. A, B, the adjacent side is C. And again we consider that A is a vertex and the adjacent side is D. In this graph also we consider that by joining B to E, this becomes A is a vertex and opposite side is D, like this. Okay, this is another type. Now we'll see. Please know that this is not the only way to define the isomorphism, as a graph G has n vertices and graphs as m edges. The number of bijection from vertex is m naught and the number of bijection from the edges is m naught. So that m factorial and factorial. So that total number of pair of functions to check is n factorial into m factorial. Goodness gracious, that's a lot of possibilities, and because there is no efficient or one size all approaches for checking whether two graphs are isomorphic, the best method is to determine if a pair is not isomorphic. Instead, check the vertex edges and degrees. The first thing we do is count the number of edges and vertex and see if they match. Then we look the edges sequence and see if they are also equal. Next we look the longest cycle as the first few questions have a problem. And lastly we will relabel using method 2, a generative isomorphism. For the above example, you will see the degree sequence is the best way for use the determining the two graphs and isomorphic. Challenges in solving graph isomorphic problems. The main challenge in solving the graph isomorphism problem is the lack of comprehensive algorithm. Graphs with a large number of vertices and complex structure poses additional computational challenges. The problem becomes even more difficult when dealing with sparse and irregular graphs. We should learn the algorithms to solve the complex structure of a graph and even write the code for graphs in DSA for easy solving. Okay. Application graphs are commonly used to encode the structural information in many fields, including computer vision and pattern recognition and graphs matching. Identifi- Identification of similar between graphs is an important tool in these areas. It is used in image recognition, pattern matching, and object detection tasks. In chemistry, graph isomorphism is a crucial for identifying molecular structure and predicting chemical properties. Chemical database search is an example of graphical data mining where the graph congregation approach is often used. Now we will see the conclusion. The graph is an isomorphism problem is a challenging problem in a data structure. Okay, it involves determining if two graphs have a same structure can be rearranged to be identical. Various approaches such as conical labeling and algebraic method have been developed to solve these problems. Research in graph isomorphism problem is an ongoing area of study. Recent advancement, including improved algorithms based on both combination and algebraic method, future research direction including exploring quantum algorithm and parallel computing approaches. Thank you.